Myself Marin Pizza from Department of Mathematics and Physics. Today we will discuss about second order linear differential equation with constant coefficient. I think you all know about differential equation. What is a differential equation? A differential equation is an equation that relates one or more unknown functions and their derivatives. Now we are going to discuss about how to solve a second order linear differential equation with constant coefficient. First, we will look into the general form of a second order linear differential equation with constant coefficient. The general form is ay double dash plus by dash plus cy equal to 0. We will solve this second order linear differential equation with constant coefficient by writing a characteristic equation or an auxiliary equation. An auxiliary equation is also called characteristic equation. The characteristic equation corresponding to this differential equation is am square plus bm plus c equal to 0. That is, this is a quadratic equation. The coefficient of m square will be the coefficient of y double dash, and the coefficient of m is the coefficient of y dash, and the constant term is the coefficient of c. So this is the auxiliary equation corresponding to the general form of a second order linear differential equation with constant coefficient. We can solve this quadratic equation by the formula, by the quadratic formula m equal to minus b plus or minus root of b square minus 4ac divided by 2a. Okay, while solving this, we will get two roots. Before that, we have three cases, that is, we are discussing about the three cases. The case 1 is, suppose b square minus 4ac is greater than 0. That is, the term inside the root is greater than 0. When b square minus 4ac is greater than 0, we will get two distinct real roots m1 and m2. When b square minus 4ac is greater than 0, we will get two distinct real roots, say m1 and m2. Then we can take one solution y1 as e raised to m1t and another solution y2 as e raised to m2t. Hence, the general solution of a second order linear differential equation with constant coefficient and b square minus 4ac greater than 0 can be written as y of t is equal to c1 e raised to m1t plus c2 e raised to m2t. And the case 2 is b square minus 4ac equal to 0. Suppose the term inside the root is equal to 0, then while solving the quadratic formula, we will get repeated real root, say m. Then we can take y1 as e raised to mt and y2 as t e raised to mt, and the general solution will be of the form y of t is equal to c1 e raised to mt plus c2 t e raised to mt. This is the second case. And the third case is, suppose b square minus 4ac is less than 0. The term inside the root is less than 0. Then while solving the quadratic formula, we will get complex roots, say alpha plus I beta and alpha minus I beta. Then we will take y1 as e raised to alpha plus I beta t and y2 as e raised to alpha minus I beta t. And the general solution will be of the form y of t is equal to e raised to alpha t a cos beta t plus b sin beta t. By using these three cases, we can solve any second order linear differential equation with constant coefficient. Now we can solve the questions. First question, solve y double dash plus 5y dash plus 6y equal to 0. This is a second order linear differential equation with constant coefficient. The first step is to write the corresponding auxiliary equation. What will be the auxiliary equation corresponding to this second order linear differential equation? The auxiliary equation is m square plus 5m plus 6 equal to 0. M square plus 5m plus 6 equal to 0. That is, m square means the coefficient of m square is 1, since here the coefficient of y double dash is 1. The coefficient of m is 5 because here the coefficient of y dash is 5, and the constant is 6 since the coefficient of y is equal to 6. This is the corresponding auxiliary equation. We can solve this auxiliary equation by using the quadratic formula m equal to minus b plus or minus root of b square minus 4ac divided by 2a. Okay. While solving this, we will get two roots. One is m1 is equal to minus 5 plus 1 by 2, that is minus 4 by 2 is equal to minus 2, and m2 is equal to minus 5 minus 1 by 2, that is minus 6 by 2 is equal to minus 3. That is m1 is equal to minus 2 and m2 is equal to minus 3. What is the general form of a second order linear differential equation? Here we can write y is equal to c1 e raised to m1t plus c2 e raised to m2t. Okay. So here the m1 is minus 2, that is c1 e raised to minus 2t plus c2 e raised to minus 3t. Okay, this is the solution of this differential equation. So next question, solve y double dash plus 2y dash plus 5y equal to 0. We can write the auxiliary equation corresponding to this. The auxiliary equation is m square plus 2m plus 5 is equal to 0. Then solve it. M is equal to minus b plus or minus root of b square minus 4ac divided by 2a. While solving this, we will get two roots, that is minus 1 plus or minus I. The two roots will be m1 is equal to minus 1 plus I and m2 equal to minus 1 minus I. Okay, we will get two distinct complex root. One is minus 1 plus I and another is minus 1 minus I. So what is here, what is alpha? Alpha is equal to minus 1 and beta is equal to 1. Okay. Then the general solution is of the form y equal to e raised to alpha t a cos beta t plus b sin beta t. Okay. Now we can substitute the value of alpha and beta. Here alpha is minus 1, so e raised to minus t into, and beta is 1, a cos t plus b sin t. This is the solution of this differential equation. So this is all about solving a second order linear differential equation with constant coefficient. Thank you.